Greetings, everybody. This is the last video covering online lab number 6. I call it the Energy Skate Park. Now, remember, we're doing the third spreadsheet, which now it's the playground with friction. Okay, so what you want to do is you go to the simulation, and you want the mass to be probably near the small end, and we don't want a lot of friction. We want the friction to be down near the lower end, but we want some. So probably right about there is good. The reason being is we want the skateboarder to make at least 8 passes over the track. What do I mean by that? Well, notice I've got a relatively small mass, not a lot of friction, a little bit of friction. Let me go ahead and start him at 8 meters. Right here, the initial height is 8 meters. And that's what I mean. In other words, for each pass along the track, I want to, in the simulation, I want to record the speed at the first low point, the speed at the second low point, then the speed at the midpoint, or actually the speed at the peak. Right here, I call it the midpoint. I mean the peak. So I want, for each pass, I want V low, V low 2, and V mid. And again, you don't want too much friction. You want them to be able to make at least 8 passes over the track. And this should do it. In fact, let me show you. Let me just take him, put him up here. Initial height is 8. And what we're doing is I just want to make sure that he can, by 8 passes, what do I mean? Well, I'm going to leave it in normal mode and hit play. And I'll tell you what I mean. Okay. This is the first pass. That's 1. Okay, this is the second. That's 2. 3. 4, 5, 6, 7, 8, and that's 9, and he might get one more. That's 10. And so he got 10 passes. Now he's stuck. All right, so that's what I mean. So you want him to be able to make at least 8. And I know that with this setting, he can make 10. So what I want is I simply first, with the simulation, I want to get the speed at the first low point, right here. Okay. Then I want the speed at the midpoint, meaning at the peak, right here at the peak. Then I want to record the speed at the second low point. From the simulation. Okay, so that's what I want to do. Then I want to calculate the energy at the low point, the energy at the midpoint. So I want the energy at the low point, the energy at the midpoint, and then the energy at the second low point. So again, from the simulation, V low 1, meaning energy at the first valley or the first trough. Right, that's V low 1. Okay, then V mid, that's the speed at the peak, right here. Then V low 2. Okay, that's the speed at the second low point. I'm getting those from the simulation. Nothing complicated. Now, so what about the initial energy? Well, remember, the initial energy, the skateboarder, we're starting from rest. And we're just doing this once. We're starting from rest. And he makes, again, 1, 2, 3. You get the idea. He's going to make 10 passes. Well, the initial energy, remember, he's starting from rest. Okay? So his initial energy is mgh. So you got to go ahead and type in that equation here. Where notice G is in cell F4, M is in F5, H, the initial H, is in F6. So his initial energy is going to be equal to mgh, or cell F5, $F, $5. See, that's the mass. We're using 1 kilogram, times G, $F, $4. That's mg. Then H initial is F6 times $F, $6. Okay, that's the initial energy. Okay, 78.4. Now that's going to be the total energy. No matter what, the total energy is always going to be 78.4 joules. But what happens is each time he crosses the track, he's going to lose more energy due to friction. But that's how you calculate the initial energy. It's just mgh. Okay, you get that in there. Now, what about the energy at the low part? What about the energy at this low part, and then the energy at the second low part? You know, here and here. Well, remember, at the low part, the energy is entirely kinetic because he's at a height of 0. So what you'll do is I'm going to go slow motion. I've set him back up to 8. This is going to be the first pass, right? I'm doing the first pass, and I first want to get the V's, and then we'll look at how to calculate the energies. So I want V low 1, E low 1, V mid, E mid, V low 2, E low 2. Okay, but the V's I'm going to get from the simulation. So let me go ahead and run that simulation. I'm at slow motion. I want to get the speed right at the low point. Okay, pause it, inch forward. Right there, the PE is 0. His speed is, again, it's 2, 4, 6, 8, 10, 12. That looks to be about 12.2. Again, we don't have to be exact, but it looks to be about 12.2. Okay, now let me get V mid. Okay, let me go back to it's a little bit tedious, but it is what it is. Now I'm going to start it, and you want to be very careful. You want to be able to get V mid, meaning the midpoint or the peak. Okay, we're going to inch forward. Click. Maybe one more. Okay, now the speed is again 2, 4, 6, 8, 10. It looks to be just about 10.4. It's not quite 10.5. It looks to be about 10.4. That's V at the mid. 10.4. Now go over here. V at the second low point. You just got to be careful. Play, pause, inch forward. Okay, right there, 0 potential. So the speed is again, that's 2, 4, 6, 8, 10. It looks to be just about 12. Maybe 11.95. Okay. Now then, to get the values for the second pass, you don't reset the simulation. Just hit play. Because right now, I'm on my first pass. Hit play. Now here's the second pass. Now watch. Okay. Slow it. Pause it. This is going to be my second pass. Go down when he's right at 0. Okay, right here. Now, the V low is, again, 2, 4, 6, 8, 10, 11, 12. Just 2, 4, 6, 8, 10, 12. That's 11.5. Okay, so that's going to be over here. Okay, because now I'm going the other way. So I'm typing it over here. That's 11.5. Now let me go ahead, get the speed at the mid. Remember, I just want to always go, because I'm going the other way. That's, I actually think it really matters, but I'm just going to, now I'm going to go, in other words, the second pass, I'm going right to left, then third pass, left to right again. So now let me get V mid. Looks like 2, 4, 6, 8, 9, about 9.4. Okay. So now let me go ahead and get the speed at the other low point. Again, it's a little bit tedious, but remember, you don't want to reset the simulation. Now this is my second, because I'm doing my second pass. Oop, I missed it. But you get the idea. Now this would be my third pass. So right here, oops, this will be my third pass. V mid, that's 2, 4, 6, 8, looks like 9. So for my third pass. But you get the idea. So you fill all those out. But remember, again, you set them up at 8, and again, this is the first pass. So that's V low 1, V mid, V low 2. Now this is the second pass. V low 2, V mid, V low 1. Okay, now my third pass, I'm going left to right again. V low 1, V mid, V low 2. Now my fourth pass. Fourth pass, I'm going right to left. V low 2, V mid, V low 1. So you just keep going, nothing complicated. All right. So you enter all those in. Now, how do I calculate the energy at the low part? So how do I calculate the energy at the low part here and the low part here? Well, let's look at the instructions. Well, remember, at the low parts, the height is 0, so there's no gravitational potential energy. All right? Because remember, we're assuming that the reference point is the bottom, i.e. the ground. So at the two low points, the energy is all kinetic. So you have the energy at the low point is 1/2 m V low squared. Okay? So I have to enter this equation into cell D11. Okay, let me go ahead and do that. So right here, D11. And I want it's kinetic, so it's equal to, and it's going to be 1/2, so in parentheses, just do 1 divided by 2. Oop, I don't need the 9 there. So I have my outer parentheses and another left parenthesis, 1 divided by 2, close, then times. The mass is in cell F5, $F, $5. That's 1/2 m, then times V squared. So times C11, so I'm going to do parentheses, C11, right, because that's where the simulation speed is, C11 squared. 1/2 m V squared, and then close, hit check. Okay, that's fine. Remember, we're calculating the energy. Now, how much energy, now here's what we're doing. It started off with an initial energy of 78.4 joules. The kinetic energy at the first low part, at the first pass, the energy when the skater was here, the energy is all kinetic. That energy is 74.42 joules. So how much energy did it lose to friction? Well, just take the initial energy, which is F7. So here do equals left $F $7. I did plus, not equals. So I'm getting a little bit tired. So equals left parenthesis. Then it'd be $F $7. That's the initial energy. Then so what did it lose to friction? We'll take the initial minus the kinetic, which is D11. So do minus D11 and hit check. And now notice the total energy will always be 78.4. In other words, on the first pass, it lost 3.98 joules due to friction when it hit the first low point. Now, how do I get the energy at the second low point? Well, it's this formula. I just want to copy it. That's 1/2 mv squared. I want to copy it, paste it there, but I'm going to have to change the cell reference because this nope, it's good. It's K11. Perfect. So it automatically updated it. Now, how much energy did it lose to friction? Well, I got to copy this formula and do paste. Yeah. And notice, just as a check, so notice it lost 3.98 joules of friction as it approached the first low point. Then it lost almost 7 joules of friction. It's lost 7 joules due to friction after it's gotten to the second low point. Now, what about the energy at the midpoint? Well, remember, at the midpoint, it's moving. Remember, at the midpoint, the energy, its potential, because at the midpoint, you're above the reference point, and so you have potential energy, and the skateboarder's moving, so it has kinetic energy at the midpoint. So it's got potential because it's above the reference, and it's got kinetic because it's moving. See? As when the skateboarder goes over the midpoint, he's moving and he's above the reference point. Okay? So the energy, the total energy at the midpoint is the kinetic energy plus the potential energy. 1/2 m v mid squared plus mg h mid. You know, that's the kinetic plus the potential. Well, we've got to type that formula in. So I'm going to type it in right here. And it's going to be equals, left parenthesis, 1/2, okay, oops, 1/2, not 23, so I want to get this, so 1/2 times, remember the mass is $F, $5, yup, see, 1 kilogram, okay, so that's 1/2 m v squared, so do times, then parentheses, the v is in G11, see, G11, bracket squared, I've got an extra parenthesis right there. So now I have 1/2 m G11, that's v squared, okay. Then remember I have to do plus mg h mid. So I have to do plus, again, $F, $5, that's m, times $F, $4, that's my g, that's mg. H mid is not going to change because the peak is, again, H mid is always 2. So then it's going to be times $I, $5. Yes. And then close the parentheses and check. Yep. So the energy at the midpoint is 73.68 joules. How much did it lose to friction? Well, just do copy and paste. And notice the total will always be the same if we do things correctly. So in other words, it's lost almost 4 joules of friction on the first pass. It loses almost 4 joules of friction approaching the first low point. Then it's lost now 4.72 joules of friction as it gets to the peak, and then it's lost almost 7 joules of friction when it got to the second low point. Then go ahead and then when he's on the way back, again, first pass you're going, this would be V low 1, V mid, V low 2. Then on the second pass, when he's going the other way, V low 2, V mid, V low 1. Now the third pass, V low 1, V mid, V low 2. Fourth pass, V low 2, V mid, V low 1. So fill out the simulation values, then with all the formulas, just copy them and drag them down. And I know this video is a little bit long, but hopefully this will work. But you want to make sure you set your mass and friction. You want at least 8 passes. You want the skateboarder to make at least 8 passes over the track. Again, that's 1, 2, 3. I mean, you get the idea. Again, on the way back, that's V low 2, V mid, V low 1, V low 1, V mid, V low 2, V low 2, V mid, V low 1. I mean, you get the idea. Alrighty, let me go ahead and get this video saved.